Greetings, ladies and gents, and welcome back at Mike Medicine Science Club. In this video, we'll be looking at a question which was written in November 2019. It's a question on finance. So they say that two friends, Kuda and Tabo, each want to invest 5,000 for 4 years. Kuda invest his money in an account that pays a simple interest at 8.3 per annum, which means of course per year. So at the end of 4 years, he will receive a bonus of exactly 4% of the accumulated amount. So they said that Tabo invests his money in the account that pays interest at 8.1 per annum, compounded monthly. They said that whose investment will yield a better return at the end of 4 years. Justify your answer with appropriate calculations. Now, I'm sure, ladies and gentlemen, you know who will, of course, get more money at the end. We know that this, of course, would be Tabo. Why? Because in this case, we know that, of course, the compound interest in this case is actually more powerful than the simple interest. So if there's anyone, of course, that says no, it's gonna be Kuda, I bet that I'm gonna bet that person 200 rand. So if, of course, I find that Kuda gets more income, or at the end, of course, in this case, than Tabo, that person must just say that, say, Mike, I want that money, I want the bet. So they said that, of course, whose investment will yield a better return at the end of 4 years. Justify your answer with the appropriate calculations. So let's say that who will, of course, accumulate a better amount at the end. But I can bet you, ladies and gentlemen, that Tabo will exactly get an amount that's actually better than that of Kuda. So let's see. So we know that, of course, Kuda. Let's just find out. So we know that, of course, for Kuda, in this case, he was, of course, using simple interest, right? So in this case, or he or she, we are not sure. So in this case, we know that, of course, Kuda is using a simple interest. Now we know that simple interest formula goes as A is equals to P 1 plus I, right? IN, rather. IN. And in this case, for Tabo, that would be the compound interest formula. So in this case, we have A being equals to P 1 plus I all raised to N. So in this case, I'm just going to start by Kuda's investment. So in this case, so that I can surprise you by by Tabo's by the amount that will be, of course, calculated by that will be, of course, received by Tabo. So in this case, for Kuda, we know that, of course, we want to know, of course, the accumulated amount right at the end. So we know that, of course, the investment, right, was they invested 5,000. So in this case, our P would be 5,000. All right. So in this case, that would be 1 plus our interest. Now remember that was actually 8.3% per annum, which means once per year. So in this case, this would just be, now if we convert that into decimal, so in this case, this would just be 0.083. But in this case, multiplied by 4. So in this case, if we put that into a calculator, let me just put the calculator. So we have 5,000, all right, open bracket 1 plus 0.083 multiplied by 4, and this actually gives us an amount of 6,000 and 6,660. 660. Let me just erase that. So in this case, this would be 660. So this would be the amount that Tabo will get. So in this case, let's now again, let's not forget, they said that he will receive exactly 4% of the accumulated amount. So in this case, of course, we know that the amount that Tabo Kuda will have right at the end would be, he would also get 4% of that 6,660 amount. So in this case, we would add the 10% of that 6,660. So that would be 6,660. All right, and then you multiply that by 0.04. So in this case, this would be 4%. So in this case, we will put that into the calculator. So we have 6,660 multiplied by 0.4. So that actually gives us so that's actually 0.4. So that gives us 266 and 4 cents. So in this case, if we add to that, if we say plus so if plus 6,660. All right, so in this case you would actually get the amount right at the end being 6,926 and 4 cents. So in this case, this would be the amount that Kuta will have right at the end. Now let's go for Tabo and see the amount that he will have at the end. So in this case, we know that of course they invested the same amount of money, right? But in this case, for Tabo in this case, they say that his interest was actually at. Let me just scroll up. His interest was actually at 8.1% per annum compounded monthly. So in this case, we know that of course if I write the shopping list, so A in this case would be the unknown, right? But in this case, P would be 5,000. But in this case, we know that of course I would be that 0.081. But in this case, divided by 12, because this interest was actually compounded monthly, meaning that interest would actually be divided into 12 equal parts per year. So in this case, of course, we would know that N in this case would be 12 multiplied by 4. All right. Now remember that N would be the number of times interest is added. Now remember that in a year, interest would be added 12 times, right? So in this case, in 4 years, we just multiply that by 4. So in this case, what you would get, so 12 multiplied by 4 would actually get 48. So in this case, N would be 48. So we know that of course P was given as 5,000. All right. So in this case for Tabo, they didn't actually add any special, of course, I mean, just like Kuda for that, they didn't give him any bonus in this case. So in this case, this would be 1 plus our interest, which is 0.081 divided by 12, but all raised to 48. So in this case, we know that let's just put that into the calculator. So we have 5,000 multiplied by 1 plus 0.081, divide that by 12. We raise that to 48. So in this case, well, my bad, ladies and gentlemen. I think actually I'll take back what I said. I'll actually take back what I said. So in this case, Tab would actually get an amount of 6,905. So this would be 6,000. So that's 6,000. Now I can't even write that 6 now. So this would be 6,905. And of course, how many cents? And 71 cent and 71 cent. I definitely take back what I said, ladies and gentlemen. I take it back. So in this case, of course, in reality, of course, if we don't consider that bonus in this case, so in this case, I would have won. By the way, so they said that 6.2. 9 years ago, a bank granted Mandy a home loan of 525,000. This loan was to be repaid over 20 years at an interest rate of 10% per annum compounded monthly. They say that Mandy's monthly repayment. So we know that, of course, this is actually a present value annuity, right? So they said that Mandy's monthly repayments commenced. Damn, that English. So in this case, they said that commenced exactly 1 month after the loan was granted. Yeah, let me not say anything, ladies and gentlemen, about that word. I don't know what it means, but I can definitely assure you that I'm gonna be able to answer those following questions. So what they are actually simply saying about, from my understanding, would be that this monthly payments started exactly 1 month after the loan was granted, which is of course the tease and apply of that present value annuity. Now remember, it works in a way that of course the first payment is actually made one-time period after the loan, or the loan is granted, in this case if it's a loan. So what I'm gonna do, I'm just gonna erase what we have here, right? So in this case, as we erase this, the deal, of course, is also being erased. So again, so what we have here, we know that of course it will use a present value annuity. So in this case, we know that this is of course an annuity, right? In particular, a present value annuity. So they said that Mandy decided to make monthly repayments of 6,000 instead of the required 5,066 rand and 36 cents. So in this case, this was actually the required monthly payment, but in this case, Mandy decided to say, you know what, I'm not even gonna take that. Let's just raise it to 6,000 instead of that 5,066. 6 rand and 36 cents. So they said that how many repayments will she make to settle the loan. So in this case, we know already that we're gonna use the present value annuity, right, which says that PV is equals to X 1 minus 1 plus I, all raised to negative n, and we divide all of that by I. So in this case, we know that of course PV, we know that of course that would be that to 5,000. 525,000 rather. So in this case, we would have 525,000, right? So that being equals to, we know that of course the monthly payment in this case was 6,000, right? So in this case, we would have 6,000 multiplied by 1 minus 1 plus 0. Now they say that the interest was actually a 10% per annum compounded monthly. So meaning that we're gonna take that interest, then we're gonna divide it in exactly 12 equal parts per month. So in this case, this would actually be 0.1, or divide by 12, and all of that is raised to negative n. Now remember, we don't know the number of payments, right? So that's what they actually want us to calculate. They said that how many payments will she make to settle the loan. Now we know that of course n in this formula actually stands for the number of the number of payments. So this would actually be divided by so this would be divided by 0.1 divided by 12. So what I'm gonna do, I'm just gonna take this and then I'm just gonna multiply it by that 525,000. So in this case, what I would get, so if I say 5,000, so I'm just gonna say 525,000. In this case, multiplied by rather, so that's 525,000. In this case, multiplied by, so this would be 0.1 divided by 12. Just want to see if of course we're gonna get smaller values. In this case, that would be divided by 12. So we actually get a value of 4,375. So we actually have 4,375. So this is actually equals to 6,000, right, multiplied by 1 minus rather. So that would be 1 minus, so that's 1 minus 1 plus 0.1 divided by 12, and all of that negative n. All right, let me just scroll down. So in this case, what we have, so what I'm gonna do next, I'm just gonna divide by 6,000 on both sides. So if I divide by 6,000, let's see what we're gonna get. So I'm just gonna divide by 6,000. So in this case, we have 4,700, it's actually 4,375. We divide that by 6,000. So what we get would be that that decimal there, which has a lot of values, but I'm just gonna keep it to that fraction. So this would actually be 35 divided by 48. So in this case, this would actually be equals to 1 minus 1 plus 0.1 divided by 12, all to the negative n. So what I'm gonna do next, I'm just gonna, let me just reverse that to erase what I did there. So in this case, what I'm gonna do, I'm just gonna take this, what I have right here, and then I'm gonna of course transpose it to that side. Then I'm gonna take what I have here to the other side. So in this case, what I would eventually have if I do that would be, I would actually, so that's actually negative n, right? So in this case, would actually have 1 plus 0.1 divided by 12, all of that to the negative n. So this would actually be 1 minus, so in this case we have 35 divided by 48. So in this case, I'm just going to put that again into the calculator. So we have 1 minus, in this case, 35 divide by 48. So in this case, what we have would be actually 13 over 48. Again, yeah, this would be 13 over 48. So this would have 13 over 48. So this actually equals to 1 plus 0.1 divided by 12 all raised to negative n. Now, of course, I'm sure you can already know that from this point, what we're gonna do, we're gonna use our logs. So in this case, what we'll do would be to say that, right, so we know that of course in a log we have 3 parts, if I'm not mistaken. So we have, so let me just say, so we know that the log has what we have, of course, down here. So in this case, this would be the base, right, which would be that. And then of course we also have another bracket there. So this would actually be, of course, for the solution. So this would be for the solution, what we have, of course, in the solution part. So this would be our solution in this case. So in this case, what we're gonna do, we're gonna say, right, now remember, of course, so in this case, what we have there as the power would actually become the subject of the formula. So in this case, what we would have would be negative n, right, subject of the formula. So in this case, we would have log of the base. Now, what's the base? The base would be 1 plus 0.1 divided by 12. So this would be 1 plus 0.1 divided by 12. In this case, what we would have, of course, in that other bracket would be the solution, which is 13 over 48. So this would be 13 over 48. So if we put that into the calculator, let's see what we are gonna get. So we have, so this would be log. So in this case, we would have 1 plus 0.1, right, divide by 12, and of course all of that is raised to, so we have that to be 13 divided by 48. So what we have actually would be 157.40. So in this case, we would have our n. Now, what I'm going to do, I'm just going to divide by negative also on both sides so that I get rid of that negative there. So in this case, we would have n being equals to 157.40. So that decimal there, it actually stands for the final payment that you would actually make, a final payment that is actually less than that monthly payments if it's monthly. So in this case, of course, to settle the loan fully, right, in this case, Mandy would actually need to make exactly 158 payments. So in this case, we know that, of course, so they say that how many payments, right, Mandy would actually make. So in this case, Mandy would would need to make exactly 158 payments. So in other words that you could have put this was to say that, of course, Mandy would actually make 157 full payments of 6,000 and a small amount. So that would have been, of course, another way you would have actually put this. So in this case, you would have said, of course, Mandy would, of course, need to make full payments of 6,000. Would need to make 157 full payments of 6,000 and a small amount at the end. So in this case, of course, that would be, of course, the final payment. So of course, for the following question, they say that after making monthly repayments of 6,000 for 9 years, Mandy required money to fund her daughter's university's fees. She approached the bank for another loan. Instead, the bank advised Mandy that the extra amount repaid every month would be recorded as an investment, in that she could withdraw this full amount to fund her daughter's studies. They said that calculate the maximum amount that Mandy may withdraw from the loan account. Now remember that the money that, of course, Mandy was actually paying, that 6,000, where is it? So that 6,000 was not the required amount, right? So in this case, she said that, you know what, let me just pay, you know, an extra amount in this case, so that of course I can finish, you know, early. But in this case now, of course, at the end, of course, Mandy needed, you know, the money in this case to fund her daughter's studies. But the bank said, you know what, instead of you taking another loan, why not regard, you know, those extra payments that you were making, right? In this case, why not regard it as let's say an investment aside. So in this case, we know that, of course, so in this case, that extra amount that, of course, Mandy would have paid. Now, remember that 566 rand and 36 was the required, right? So in this case, she made, you know, an extra payments in this case. So in this case, let's find out that how much was, of course, that extra payment, and then, of course, we would take that and regard it as an investment aside. So in this case, we would know that, of course, we have. So let's calculate the extra. So that would be the extra money. So that would actually be equals to that 6,000 minus 5,000 for 5,000 and of course 66 rand. So that's a zero there, and 36, if I'm not mistaken. Yes. So in this case, we have 6,000 minus 5,066 rand, and of course that 40, so that was actually 36 and 36 cents. So in this case, the extra amount was actually that 933 and 64 cents. So in this case, this would actually be equals to 933 and of course that 64 cents. So it's 64 cents. So the bank said, you know what we're gonna do in this case, we're just gonna regard that extra amount that you paid as an, you know, an investment. So in this case, we want to find out that how much would all of these payments, all of this extra be worth, of course, in this case, after of course 9 years, right? So in this case, they said that calculate the maximum amount that Mandy may withdraw from the loan account. So in this case, so what we're gonna do now, remember now, this is no longer present value annuity, but rather a future value annuity, right? Because in this case, we can regard this as a you know, an investment that is of course paid every month, right? So in this case, we want to find out that how much will all of those extra be worth in the future. So what we're gonna do in this case would be to use the future value annuity formula, which says, of course, let me just erase that we have, you know, somewhere to write. So in this case, we know that the future value annuity says that FV is equals to x multiplied by 1 plus I divide all to raised to n minus 1. All of this is divided by I. So in this case, of course, we want to find out the future value of all of those excess 333 rand and 64 cents right after, of course, after that after 9 years. So in this case, we would know that x would be that 933 rand and 64 cents, right? All of that is actually multiplied by 1 plus, now in this case the interest would regard it as the same, which is that 10%. So in this case, this would be 0.1 divided by 12. In this case, now in 9 years, now remember that Mandy is actually making monthly payments, right? So in this case, in 9 months, in 9 years rather, now remember that in a year she would make 12 payments. So in this case, in 9 years, in this case, that would actually, so the number of payments would actually be 9 multiplied, it would actually be 12 multiplied by 9. So in this case, it would be 108 payments made in 9 months, so in 9 years rather. So in this case, we would know that n would be the number of payments. So in this case, it would be 103. So in this case, this would be 103. Actually, no, that's 108. So this would be 108. 108. So in this case, we would know that all of that is actually divided by I, which is 0.1 divided by 12. So if I put that into the calculator, so we have 933.64 multiplied by 1 plus 0.1, divide that by 12, and in this case we just close that. And then so in this case I think I actually made a mistake. That was supposed to be so we had to have a -1 there, so this is actually divided by 12. So let me just erase such that I have a -1 in there. So in this case we also have -1. All right, so in this case this would be, so let's just continue to put that into the calculator. So we have the power being 108. All right, so in this case this would actually be, so we subtract the 1 from that, we divide all of that by 0.1, or divide by 12. So in this case what we would have in this case would be 162,500 and 3 rand and 51 cents. So in this case the future value of all of those excess payments in this case would have been 162,000. Let me just erase that again. So in this case would have been, so it would have been 162,503, and of course that 51 cents. So this would be the amount that for those excess. So this would be the amount, the maximum amount that Mandy may withdraw from the loan account. So in this case this would be the end of today's lesson. So if it helped you, of course at some point be sure to like the video, and of course if you haven't subscribed, please become the part of this growing community. But of course if you have got any questions, please, you're more than welcome to throw that in the comment section. I'll make sure that of course I will read those comments, and of course reply in this case. So if you of course you have a question that you would love me to do, or a past paper, you are more than welcome again to throw that in the comment section. But again, ladies and gentlemen, that of course the deal is all for that 6.1. But otherwise, ladies and gentlemen, this has been fun. But as the story always ends, as you already know, that this, ladies and gentlemen, is Sir Mike signing out. Sharp sharp.